Greetings, guest of International Conference on Interdisciplinary Research in Social Sciences on 2024 Soares, Dubai. I am Varelino Setya Navyando, and I'll be presenting about my bachelor's thesis regarding how effective is the implementation of a circular economy in the European Union towards a climate change rate. This is a prevalence analysis with the Eurostat data. So a little about myself. I am Varelino Setya Navyando. I am a double degree student from Bandung Institute of Technology in the School of Business Management, majoring in international business, and I'm also part of the double degree program from the University of Groningen, majoring also in international business. So the table of contents, or what will be covered in this presentation, includes the introduction and background, followed on with the data section, followed on with the empirical methods, and then finally the findings and discussions of my thesis. So the first part is the introduction and background. The overview of my thesis investigates the impact of circular economy practices on climate change mitigation in the 27 countries of the European Union from 2010 until 2020. Utilizing data from Eurostat, it explores how the adoption of circular economy principles, focusing on resource productivity, recycling rates, and waste generation, affects greenhouse gas emissions. The study aims to clarify the role of circular economy in mitigating climate change by incorporating control variables such as GDP per capita, population density, and energy consumptions in its analysis. Through multivariate regression modeling, the research finds a significant correlation between circular economy practices and the reduction of greenhouse gas emissions, suggesting that circular economy can be a vital strategy in addressing climate change. This conclusion supports the development of targeted policies and practices within the European Union to enhance sustainability and reduce environmental impact. The research introduction includes the definition of circular economy, which is the aim to minimize waste and optimize resource through recycling, reuse, repair, and remanufacturing, offering a sustainable alternative to traditional economic models. The European Union champions this model to shift towards the sustainable consumption and production, targeting waste reduction and resource efficiency. Climate change, driven by human activities like fossil fuel combustion and deforestation, presents significant changes in climate patterns and challenges in Europe. So overall, the circular economy is key to the European Union's climate change strategy, promoting efficient resource use and a waste-free economy to cut pollution and greenhouse gas emissions. It aligns with goals for sustainable development and climate action by prioritizing waste reduction and resource efficiency, highlighting the need for systematic changes in production and consumption. However, there exists a research gap. So despite the European Union's substantial investment in promoting circular economy practices, the detailed relationship between these practices and their direct impact on climate change mitigation remains underexplored, as highlighted by Romero, Carpus, and Lazarek. Additionally, there is a noted scarcity of comprehensive studies on the overall status of circular economy research and its environmental outcomes, signaling a considerable gap in this field. So, the existing literature presents varied results regarding the circular economic's effectiveness in addressing climate change, suggesting a need for further investigation into the potential of circular economy practices to contribute to climate change mitigation. Thus, my research question is, what is the impact of the adoption of circular economy practices on climate change mitigation in the European Union? To address this question, I will use net greenhouse gas emissions as the dependent variable, noted as y, representing the climate change impact. The independent variables, noted as x, include key circular economy indicators such as resource productivity, recycling rate, and waste generation. Additionally, I will incorporate control variables to account for potential confining factors: GDP per capita, population density, and energy consumption. So here are the list of variables used. The dependent variable is the greenhouse gas emissions. The greenhouse gas emission provides a crucial measure of the European Union's environmental footprint. And then, followed by three independent variables: the recycling rate, which reflects the proportion of waste materials that are diverted from disposal and reprocessed for reuse, and then the the other independent variable, which is waste generation, which refers to the process of producing waste materials from industrial, commercial, agricultural, and domestic activities that are discarded as unwanted and useless. And lastly is resource productivity. Resource productivity quantifies the efficiency with with which resources are utilized within the economy. Next, here are the following control variables. For note, I log transformed all of the control variables because it has outliers, and it was employed to address their non-normal distribution and high kurtosis, effectively normalizing the data distribution and enhancing the validity of parametric statistical tests by mitigating the extreme values impact. So the first control variables is GDP growth, as it is included to account for economic development, reflecting a country's capacity to implement sustainable practices. The next one is the population density. It acknowledges that densely populated areas may face distinct challenges and opportunities in adapting circular economy initiatives. And lastly is the energy consumption, which is also a crucial control variable as it directly impacts greenhouse gas emissions, particularly in regions reliant on fossil fuels. So then, with these, I come up with three hypotheses. The first one is that the higher the recycling rate, the lower the volume of greenhouse gas emissions, which is backed by these three literature reviews, followed by the lower the waste generation, the, the lower the volume of greenhouse gas emissions, again, followed by three literature reviews. And lastly, the higher the resource productivity, the lower the volume of greenhouse gas emissions. And again, another three literature reviews are used as the literature foundations of all of my hypothesis development, which you can see on this following slide. And finally, this is the conceptual model of my whole bachelor's thesis or research. Following on, we'll move on to the data section. First is the data source and overview. So again, this thesis uses Eurostat as its sole data source due to its authority and completeness on the European Union data. Eurostat, the European Union statistical agency, offers reliable socio-economic and environmental data from member states. Its consistency, comparability, and adherence to strict statistical standards, as highlighted by Mayer et al., ensure data integrity and trustworthiness. This choice supports meaningful cross-country comparisons and robust evaluation of the research question, aligning with the study's objective to analyze temporal trends and impacts effectively. So here to the picture, you can see those are the variables, the types, and also the unit of measurement, as I explained before. And here is the summary statistics. So the summary statistics can be seen on this table on the right. The dependent variable of greenhouse gas emissions has a standard deviation of 4.09. The independent variable of recycling rate has a standard deviation of 15.6, where resource productivity has a standard deviation of 10,928, and waste generation has a standard deviation of 129.81. All of the variables are not highly correlated with the other variables. The correlation matrix provides valuable insights into the relationships between the variables in the dataset, and this information can be used to develop hypotheses about the causal relationships about the variables, which then can be tested using the regression model. The positive and negative result from the correlation shows the difference of effects of the independent and dependent variables that has on each other. So following on, these are the empirical methods or the statistical tests that I need to do in order for me to continue doing the regression result. So the first one is the mean estimation. This is an important tool for making inferences about the population means of variables and for comparing the mean values of different variables, as you can see from the graph on the top. And below it is the VIF. This is the use of VIF can tell if there's multicollinearity in a regression model by comparing the VIF values for each independent variables. And from the result, it shows that there is no multicollinearity. So then it's just a good sign for the variables. Following on, I need to check for the heteroscedasticity using the Bruges-Pagan test. However, it detects heteroscedasticity by showing the chi-squared statistic of 39.79 and a p-value of 0.00, which indicates there is presence of heteroscedasticity. So to address this, I incorporate a robust option for my result, ensuring a more accurate and resilient standard error estimation in the face of heteroscedasticity, thereby enhancing the regression analysis precision. Next on below it is the Hausmann test, which tests for a fixed effect. And here it shows that from the results that I will not be incorporating the random effects, but I will be using the fixed effect model. And lastly, here is the robust fixed effect regressions, which are used to correct for the possibility of heteroscedasticity in the data, which has been shown as present from the previous slide. Thus, here are the results, and the outcomes closely resemble of the previously transmitted fixed effect regression table. And finally, here are the findings and discussion of my overall research and thesis. So to your right, here you can see the result of the regression. Model 1 shows the greenhouse gas emissions the independent variable of recycling rate. It shows that it is positively linked due to higher energy demands in the recycling process. And then I continue on with Model 2. This is the inclusion of waste generation. And here again, it also finds a positive correlation with greenhouse gas emissions, which attributes to landfill and incinerator disposal methods. Next is Model 3, which incorporates the greenhouse gas emission with all of the main independent variables. Model 3 introduces resource productivity, demonstrating a negative correlation with greenhouse gas emissions, as higher resource productivities would signify efficient material use and less environmental extraction. In Model 4, the next one, is greenhouse gas emissions with all of the main independent variable, following with the control variables. So here, the addition of population density, GDP per capita, and energy consumptions are all included, which all shows positive association with greenhouse gas emissions, reflecting the impact of all of the control variables to be true. And lastly is the robustness check in Model 5, which explores a nonlinear relationship by including a squared term for the recycling rate, revealing a diminishing beneficial effect of recycling on greenhouse gas emissions at higher levels of recycling, indicated by the negative coefficient of the squared recycling rate term. So here's the final conclusion of my thesis. So this whole thesis examines the link between climate change and the circular economy, revealing mixed results for initial hypothesis. While hypothesis 1 is rejected, hypothesis 2 and 3 are supported. However, for hypothesis 1, it indicates that a higher recycling rate broadly reduces greenhouse gas emissions, which aligns with Schwartz et al. From 2021, who note the specific benefits of plastic recycling. Additionally, Sun et al. Suggests that increased resource productivity can lower emissions, a finding collaborated by regression analysis that underscore resource productivity's crucial role in emission reduction. The thesis also emphasizes the importance of other circular economy strategies, such as waste minimization, showing statistically that higher waste generation increases emission. This supports Bayer et al. From 2021, highlighting the significance of municipal waste recycling and other practices in climate change mitigation by lowering European Union's net greenhouse gas emissions. So, in summary, this thesis explores the link between circular economy and climate change, confirming the effectiveness, of large-scale recycling and increased resource productivity in reducing greenhouse gas emissions. It validates theories from Schwartz et al. On the benefits of plastic recycling and Sun et al. On the impact of resource efficiency. Additionally, it also emphasizes minimizing waste generation as key to emission reduction, aligning with Bayer et al. The findings advocate for a comprehensive circular economy approach to mitigate climate change. However, there is of course the thesis limitation. This research faces limitations including barriers to circular economy adoption like inadequate laws, lack of awareness, and financial and infrastructural challenge, as mentioned by Ida et al. And Marco Scham. The pursuit of continuous economic growth without considering environmental impact also challenges the principles of circular economy. Additionally, climate change complexity influenced by natural events such as global policies and socio-economic factors complicates isolating circular economy impacts. There is also a chance that the 2010 until 2020 study period may also be too brief for a thorough analysis, suggesting the need for long-term view. So here are my last suggestions for future researches. So for future research on circular economy's impact on climate change mitigation in the European Union, it is crucial to consider each country's unique institutional frameworks. Ratna et al. And Alonso Almeida and Anton highlight the importance of institutional factors in adopting circular economy practices. This research's findings, particularly on recycling rates and greenhouse gas emissions, underscore the need to analyze country-specific policies and infrastructures. Finally, im- understanding the diversity in policy implementation is vital for effectiveness of climate change within the circular economy framework. So that's it for all of my bachelor thesis. Thank you for your time and thank you. Goodbye.